Hello ladies and gentlemen, today in this video we are going to be talking about synthetic division. So synthetic division is a way of being able to divide without doing long division. So when you were in elementary school you were given division problems like 36 divided by, let's say, 5. And what you would do is you'd put 5 outside of a division bar and 36 would go inside, and you would see how many times 5 went into 36. So you'd start with how many times does 5 go into 3? It doesn't go in any. How many times does 5 go into 36? It goes in 7 times. You multiply 7 times 5, and you get 35. And then you subtract, and you get 1. And your answer would be 7 with a remainder of 1, right? So in algebra, we can do long division with polynomials too. It's very long, very complicated. I'm not going to show it on this video because that's not what we're going to learn today. We are going to learn synthetic division, which is an easier version of doing division on polynomials than long division. Long division is very long and complicated, so just trust me on that. So we're going to go over how to do synthetic division. So if I'm given a problem, x squared minus 5x minus 36 divided by x plus 4. The first thing I'm going to do a lot of highlighting on this video, so just follow me on it. So first thing I look at is, got a little glitch here, hopefully we're good. We're going to look at x plus 4. And we're going to look at whatever makes x plus 4 0. So when I plug a number in for x, what's going to make that 0? Well, that number is going to be negative 4. So we put negative 4 in a box. So synthetic division is kind of weird to set up and weird to calculate, but it's easy once you get it and once you get the steps down. So don't be overwhelmed by the beginning steps here. It's just a little weird to set up. So take whatever you're dividing by, whatever makes it equal 0 goes in the box in the top. Then what you're going to do is look at your exponents. So I need to make sure that my exponents go down step by step, okay? So they need to go, I start with an exponent of 2, that's my highest exponent. I need to go to an exponent of 1, and then technically that has an exponent of 0. The 36 doesn't have an exponent, so it has an exponent of 0 because there's no variable there. So we go 2, 1, 0. That's what I want. So once I check to make sure it goes down one step at a time, I take the number out front and I write that down in my synthetic division. I'm going to show you how to do that. So the number in front of x squared is 1, so I write 1 next to my box. The next number is negative 5, so we leave a little bit of space and write negative 5. And then our last number is negative 36. Leave a little bit of space next to the negative 5 and write negative 36. We leave space underneath and we draw a line, kind of like a big equal sign. So whenever we're doing synthetic division, we always bring down the first number. So we bring down the 1. Then we multiply the number in the box by the number we just brought down. So we do negative 4 times 1 is negative 4, and we write that underneath the negative 5. Then the numbers that are above the line that are lined up together, we add up. So negative 5 plus negative 4 is negative 9. And then that number I just wrote below the line, I multiply by negative 4. So 9 times negative 4 is positive 36. And then negative 36 plus 36 is 0. So that last number that you get is always going to be your remainder. So we'll talk about what to do when we do have a remainder later, but I just want to talk about how to set up our answer. So our answer is going to be a polynomial of some sort. So what I need to do is, I'm going to highlight again, I need to look at my original problem and what I started with. I started with a degree of 2. Okay, my exponent was 2 at the beginning. So I'm always going to go down by 1. So this is 1x to the first power. And then we go down by 1 step to minus 9. So my answer is x minus 9. So everything we do in synthetic division goes one step at a time in degree, okay? So I went from 2 down to 1. That's how I got x. And then I got minus 9 because my variable goes away. And then I don't have a remainder, so that's why I don't have anything after that. So let's look at another problem. So let's say I have n to the second plus 7n plus 10 divided by n plus 5. So again, I'm looking at n plus 5, and I'm looking at what's going to make that 0. So negative 5 is going to make n plus 5 0. So I put that in my box. Then I look at my exponents. I go 2, 1, 0, which is what I want. So I take the numbers out front. Oops, tried to change colors there. Didn't quite go. There we go. So I have 1, positive 7, and positive 10. So I write that down next to my box. 1, positive 7, and positive 10, and I draw a line. So we bring down the first number. So we bring down the 1. So I have negative 5 times 1 is negative 5. And then 7 plus negative 5 is 2. Then negative 5 times 2 is negative 10. And 10 plus negative 10 is 0. So my remainder is 0. So we look back at our original problem, and we look at that first exponent. The highest exponent was 2, and we go down by 1. So that gives me 1n plus 2. And I don't have a remainder, so I don't have anything else to add on to that. We're going to talk about remainders right now. So let's say I have 3z to the third minus 14z to the second minus 7z plus 3 divided by z minus 5. So this one looks a little bit different than the problems we've been dealing with. Instead of using an old school division symbol, I'll call it, we used a fraction bar. But it's the same thing as a regular division symbol. So again, I look at z minus 5, and I look at what's going to make that 0. What's going to make that 0 is positive 5. So positive 5 goes in my box. Then I look at my exponents. It goes 3, 2, 1, 0. That's what I want. I want it like a rocket ship. Like when they count off for a rocket ship to get launched. They count down from like 10 or 59. I don't know what they count from. But you want to go down step by step. So we write our numbers out front. So I have 3, negative 14, negative 7, and positive 3. And I leave a space and draw my line. So we always bring down the first number. The first number in this case happens to be 3. We just bring it down. So we do 5 times 3 is 15. Negative 14 plus 15 is 1. 5 times 1 is 5. Negative 7 plus 5 is negative 2. 5 times negative 2 is negative 10. And 3 plus negative 10 is negative 7. So I have a remainder on this one. And that's not a problem. It's really easy to deal with. So we look back at the beginning. So we start just like we did. We look at the beginning, and we started with a degree of 3. So I go down by 1. So now this is going to have an exponent of 2. So I have 3z to the second plus 1z minus 2. Then how you handle the remainder is you write down the number, so minus 7 over whatever you're supposed to divide by, z minus 5. So you do the same process for the numbers out front of that remainder, and then with the remainder, you just put it over by what you divide by. And that's our answer. So number 4, I have y to the third plus 6 over y plus 2. So we start with the bottom, so y plus 2. So what's going to make that 0 is negative 2. So negative 2 goes in our box. Then I look at my exponents. I go from an exponent of 3 to an exponent of 0. It has to go step by step. So we're going to rewrite that. So I have y to the third plus, I don't have y to the second, so that means it's 0. So 0y to the second. I don't have 1, so that's 0y. And then I have 0, and that's plus 6. So now that my exponents go 3, 2, 1, 0, I'm going to write the numbers out front next to my box. So I have 1, 0, 0, 6. We leave a space and we draw a line. So we bring down our first number, which is 1. So we do negative 2 times 1 is negative 2. 0 plus negative 2 is negative 2. Negative 2 times negative 2 is positive 4. Then 0 plus 4 is 4. Negative 2 times 4 is negative 8. And 6 plus negative 8 is negative 2. So that's my remainder. So we look at our original problem. We started with a degree of 3, so we go down by 1. So we're going to have y to the second minus 2y plus 4, and then we keep minus 2, and we put that over y plus 2. And that's how you do synthetic division. If you have any questions, please let me know. And if there's any problems with the video or quality issues, let me know about that too, because I'm recording for the first time in a while. So if you have any questions or notice any issues, let me know. And I hope you have a great day. Bye-bye.